So now I'm going to look at a couple extensions of the decision to work when everything's not free. So basically cases where it's not all black and white, where they may work, they may not. But the first thing we're going to look at is the reservation wage. And so this was discussed a little bit before, but the reservation wage is the minimum wage that somebody is willing to work for. It's the minimum amount that someone's willing to work for. And so let's just say there's no minimum wage, and let's say that the wage was $1 an hour, $2, $3, $4, $5. So for most people, they just wouldn't work in this case. All right, so their hours would be $0, $6, $7, $8. Now let's say we got to $10. Now it becomes worth it for them to enter the workforce. And when that's the case, then they will be more willing to work. And not only that, but it's not going to be just, say, starting to work 1 hour, 2 hours. Then at that wage, they may work 10 hours or 5 hours, something like that. So this just shows an example of this. So the reservation wage, again, is the minimum wage that a person is willing to work for, the minimum wage they need to enter the labor force. So let's start out by assuming a little bit of a different scenario. And let's assume that there are 2 hours of travel time. So when this becomes the case, instead of having your 16 hours, you have 14. So if you want to work, those first 2 hours of labor, essentially, you make nothing from. And with that, you have let me get the right color here. So you have a budget constraint, which for the first 2 hours of work are 0, and then you start to make your wage. So this assumes that there is a 1 hour commute out and back. So you lose 2 hours. So your budget constraint here is essentially then A, B, C. So in this circumstance, the worker needs to, or the worker, given their utility function, would choose point A down here because that's as far as they can get. However, if the worker wanted to work, they would need some sort of a raise in this case. And if the raise was, let's say, half of this. And so here's our budget constraint. Well, in this case, the point where it intersects would be somewhere, I guess, around here. So it'd be this point. Okay, actually, let's undo that for a second. In that case, it would be something like, let's do it like that. So it doesn't intersect. So it'll be somewhere along here. And they can move out on their indifference curve in this case. So they would need to continue to get a raise until they got to this point here, this curve where it's DBA for the budget constraint. And in that case, then they would get to work. And whatever the wage rate is at this point, that is what the reservation wage will be for this person. The point where they would go from working 0 hours to 4 hours at whatever that wage was. There's also cases where the budget constraint can have a bit of a spike with it. So there's some policy decisions that create a budget constraint that increases income while not reducing the take-home rate. And so an example of this is some Social Security programs compensate workers who cannot work. So consider workers' compensation. And consider, in this case, workers' compensation that pays workers the same pre-injury wage they have as long as they don't work. So you go into work and you get paid the same amount that you would have if you worked, as long as you don't go back to work. In this case, when you look at the budget constraint and the utility functions, this worker would be at, they would choose F, work E0 hours, and at $8. Or sorry, at 8 hours, rather. So they would make E0 and work 8 hours. Now they get injured. If this disability insurance was the case, where they got full pay, they would still make this E0. So if they worked, they would be, or sorry, they did not work, rather. They would be at this point right here, where they would have 16 hours of leisure and make E0. If they worked even 1 hour, this E0 would go back to 0, and then they would start to make their amounts again. So in essence, in this case, what we have is a spiked budget constraint, where if you work 0 hours, you're going to make E0, and then any more than that, you're going to go to 0, and then it's going to go up. And so your budget constraint is going to be C, A, B, or BAC, whichever way you look at it. In this case, the problem is there's no incentive for the worker to go back to work. Because why go back to work? So you can either be at C at utility 2, or go back to work at F and be at utility 1. Now clearly you're better off here by not going to work, because what ends up happening is that first hour of work is going to cost you E0. You're giving up all of that. So would you rather work 0 hours and make E0, or work 8 hours and make E0? Clearly, you would rather be over here. So the program creates some real work incentive problems. There's a negative returns to the first hour of work. So let's just say you make, let's say E0 is, let's say you make $10 an hour. And so at 8 hours, 8 times 10, E0 is 80. Okay. So see this point here, you're making $80 and working 0. By working 1 hour, you're losing that $80, but you're going to gain the $8 you worked by that first hour. So what happens is that first hour of work is going to cost you $72. So that's a problem. The other issue is because you earn the same amount, you're going to be better off by not working and having a set amount of income than working and having that same amount. The other issue is that this creates a case where the worker's reservation wage will increase. And what happens is if you look here at E2, this worker will not even consider coming back unless they absolutely have to, unless their wage rises to the point to where they get here. Because anywhere else they have no incentive to work because their indifference curve will be at a lower level. So setting the benefit to earning to the old earning does not work, or does not really make sense. And what tends to happen is that as an employer, you would want to set the wage at some fraction to get the worker to come back. And so, for example, if you set it at this small g here, well, the worker is just as well off if they're not working than if they are, because they're making less. So they're getting more leisure time with G, but they're making less money. And so anything below G let's say it's here. Well, if it was here, let's say our utility looks something like this. Okay. Well, once they can work, and we'll say this is U0. Once they can work, all right, they're not going to want to be here. They would rather be here at U1 rather than U0. So in this case, there is the incentive for them to get back to work when they can.